right? What's going on this week? Test. There's a test this week. So, don't panic on me yet. I want to go over, because we've covered an enormous amount of information in a short period of time. And I want to point out that we have, I've erased everything that was over there on the board, and I put up the periodic table that I had labeled with all the quantum numbers, I put it up over here. This is the last day it's going to be up. So if you have some things missing from your periodic table, today is the day. But we're going to do some problems where I'm going to walk you through the electron configurations, the quantum numbers, the Bohr model, and this idea of things being paramagnetic or diamagnetic. And if we can get through that information and talk about electron dot structures today, then I think we are all caught up with everything we need to be ready for your test. And you guys just need some practice. Yes? Did I make a mistake?
What day is the test?
Thursday. Yep. Okay, yes. Okay. So, what I want to do, I want to start with this example. And then, let's see where that leads us. Okay? I know we haven't talked about paramagnetic and diamagnetic yet. That we're going to do today. And I totally missed it on one of my previous slides because I got excited about quantum numbers. So, we're going to talk about that today. So why don't you tell me how you want to do this? Do you want to give it a try? Do you want to try drawing the Bohr model, identifying the quantum numbers, writing the electron configurations? I'll give you a couple minutes to do that, and then we'll go over it as a class. Some of you are saying no, you don't want to try it. Some of you are saying yes, you want to try it. So what I'm going to do is I'm going to give you a few minutes. If you don't want to try it, that's fine. You can wait until we go over it in class. But I want to give those people that want to give it a try a couple of minutes to give it a try. So go ahead now and do that.
That's like 3 feet. You go to like the end in the belt,
Mm-hmm.
and then so the area I'm confused on how like I don't remember what you on arrow school. The phosphorus is there.
So you have 15 electrons, right? That means that you're going to draw 15 arrows.
And what's the one where it's like each has to be filled? That's when you end up in the same direction.
The degenerate orbitals. Each one has to have one before any of them can happen.
So I forget like how many lines you have to fill.
So that's going to be based on the numbers you have here. There's going to be 1 for an S, there's going to be 3 for a D, 5 for a D, and 7 for that.
So there's like 3.
So you want 3 lines here.
Wait, no, let's.
Because it's in a p orbital. ready to get started with this? Go ahead. I know like I said, it was a lot of information at one time, or, well, it wasn't one time, but over a short period of time. And you haven't had any practice with this yet. So I fully expect for you to be confused. We are going to go over this. I just want to give you a chance to draw or do what you felt comfortable with or what you were willing to try before we went over it as a class. Okay? So let's go ahead and go over this, and then I'm going to talk about paramagnetic and diamagnetic, because that is related to the electron configuration in orbital notation. But I want to make sure that you're seeing the connections, and I want to make sure that you get whatever questions you have answered. Okay? So, what do you want to start with? You want to start with electron configurations, quantum numbers, or the Bohr model? Bohr model. That's good. That's where I would start too. So, how many protons and electrons does phosphorus have? 15. So 15 protons. And what energy level is it in? 3. Energy level 3. So I need 3 rings, right? And then it's got 15 electrons, so 2, 8, and 5. Is that correct? Questions about the Bohr model? Gracie?
How do you get the numbers?
These?
Yeah.
So in the first ring, the maximum electrons you can have is 2. In the second ring, the maximum you can have is 8. The third ring, you can have up to 18, but we run out of electrons after the first 5. So 2 plus 8 is 10, plus 5 is 15. We only have 15 electrons to work with. Okay? Yes.
So you go, okay, I know 2, I know 8, that's the max, but you don't have to put like another 18, you just go to the number.
Yeah, when we run out of electrons, we've got no more. So even though it can hold a maximum of 18, we only have 5.
So we're only gonna put like 5.
Mm-hmm. Okay? Any other questions about that one? Okay. So what do you want to do next? Quantum numbers? Alright. So I'm not going to write out the letters, but they always go in the order of N, then L, then M sub L, then M sub S. They are always in that order. So let's go over here to my periodic table on my board. You have the one in front of you, right? So phosphorus is right there, right? Okay. So we're looking at the quantum numbers for the 15th electron, that last electron. First quantum number is energy level. What energy level is phosphorus in? 3. So its energy level, the N value, is 3. All right. Now we have to define L. L is the orbital set. So if we know where phosphorus is, what orbital set is it in? It's in the p orbital set, right? And what's the L value for the p orbital set? 1. So the next value is 1. Now we have to define M sub L. M sub L is the specific orbital within that set. Specific orbital within that set. The M sub L values here are in pink. So what M sub L value does phosphorus have? 1. I'm going to get my steps today on my watch. Last one is the M sub S value. So if I know where phosphorus is located, what is the M sub S value for phosphorus? Plus 1 half. Questions about quantum numbers?
What did you say M sub S meant?
Spin. Spin up is positive 1 half. Spin down is negative 1 half.
You have to write plus 1 half, or can you just write 1 half?
I always put the plus, and here's why. Because some of you, when you're scribbling all over your paper and you don't erase completely, sometimes it looks like this. Should I take that to be a negative sign? But if you physically write the positive sign there, I'm gonna look at that and I'm gonna say, oh, that was probably something that didn't get erased completely, they dropped their pencil, something, right? So I always write the positive sign. Yes, Amir?
Okay, so 3 is the energy level.
Yep,
What's the first one?
that is the orbital set. So that's gonna be S, P, D, or F. And you see here, that's in orange. Phosphorus is in the p orbital. So the L value equals 1. Okay? Owen?
How would you like us to write them out? Would you like us to write them out like that, or would you like us to label each of the values?
It's entirely up to you. But if you write your numbers out like this, I'm gonna assume it's N, L, M sub L, M sub S. So if you're gonna do them out of order, which you should never do, then you better label them. Okay? It doesn't matter to me, I see them the same way. Other questions about quantum numbers? No. Yeah. So I wanna make sure everybody heard that. On a test or quiz, you cannot use this. This is only to get you started. This is only to get you started.
So we can't use this?
We can't use that Thursday? So you have to memorize it.
You don't expect us to get the
Aren't we
answers.
doing this on our test?
Yes.
You will be, yes. I don't want you to memorize it. I don't want you guys to ever memorize anything. I want you to understand how it's put together. I was clear about that. I said it multiple times from the beginning. It is only to help you get started. It's only to help you get started. Because if I let you use that, and then you're just going through the motions here, what have you truly learned? Exactly. And I know that some of you are incredibly frustrated at this point because you don't know, you're not seeing the connection. We need to go through this so that I can show you what that connection is. But like I said, you have to be able to trust me so you can see it. All right? Other questions?
We're still allowed to use our regular periodic.
Yes, you will still be allowed to use your regular
Oh,
periodic
okay,
table.
I took it as like we couldn't use anything.
Oh, no, I would never take the regular periodic table away from
So
you.
we just
But
have to
you can use that one.
So we just have to understand all of this, but just not written on our other
Right.
periodic table. Okay, that's fine.
Right.
I was like, you want me to memorize all these numbers?
No, Lord, no. I don't have them all memorized. I know enough where I can find what I need. That's all I know. Okay? Other questions about quantum numbers?
Not about, but on like a test, are we gonna have to draw a wormhole for the ones where that we don't know how to switch to electrons?
Like beyond calcium?
Huh?
You don't know how to switch the
No,
electrons.
like,
Isn't that milk?
So like there are 18 here.
when we had, there was one example where we had to like split up the electrons.
Yes,
Will we have to do that?
yes.
How do we know how to do that?
I'm gonna show you. So, again, this follows right in line with your periodic table. You have to trust me, okay? You have to trust me. You guys have all had me in class before. Have I really ever asked you to do something that I know was not possible for you to do? Okay, so I'm gonna say the ones that said no, thank you. The ones that said yes, you're questioning in your mind. Okay. I would not ask you to do something that I'm not gonna show you how to do. I know this is gonna be helpful later. You don't see it yet, and that's okay. But trust me. You have to trust me. Okay, let's go on to the electron configurations. And this is brand new. This is what we did on Friday, and it was a lot of information really fast. So we're gonna start with orbital notation. That's the one with the arrows. Orbital notation is the arrows. Okay? It starts out the same way every single time. I'm gonna put my lines first. 1s is the first one. In your resource packets, I need to make myself a note here.
Can't we use these on the test too?
Yes, you will be able to use your resource packets on the test. That's not for you, that's for my other class. In your resource packets, I want you to turn to the page with the orbitals.
The back of the page.
Okay, it's not. The page with the orbitals, do you see the picture of the orbitals at the top? Okay, now, beneath it, you have the Aufbau diagram. That's the one with all the lines and the boxes and that goes up in energy. I want you to look at the picture beside it. This is an orbital filling diagram. I'm going to draw it up here, over here. Okay, so I just drew up here without the arrows what you have on that paper. Do you see it? Now, this is supposed to help you write these in order. And I want to just point out that when I did this, I did all my S orbitals first. 1 through 7. You don't even have to memorize how it's put together because you have it right here in your resource packet. You'll be able to use it, so I'm not even going to talk about that. But what I want to point out is that the arrow shows us the order they go in. So we draw a series of parallel arrows. Do you see it goes through 1S first? The arrow touches 1S, so 1S is first. The next arrow, what does it go through? 2S. So the next one we list is 2S. The next arrow, what does it touch first? So 2P, and there are 3 lines because there are 3 orbitals. Do you see it? That was a call from New York. I wish I was that important. Okay, so the arrow here touches 2P first. So I'm going to list 2P first. The 3 lines. Do you look up in the picture at the top? How many P orbitals are there? 3 P orbitals. Each orbital gets its own line. Okay? What does it touch after 2P? 3S comes next. And there's only one line because there's only one S orbital. How do we feel?
Oh.
Yes? That's a good question. Let me keep going here for just a moment. The next arrow touches 3P first, and there are 3P orbitals, so I'm going to go ahead and put 3 lines and label them 3P. And then what's next? 4S. We could keep going forever and ever. When do we stop?
Can we stop for it, like when we get to the orbital at its end?
Yeah. So here, remember we did this with our quantum numbers? We looked at where it's at. It's in energy level 3, and it's in a p orbital. We can stop after 3p. But could you write it all out? Yes. I don't know why you'd want to, but yes, it's like the rings. We can draw as many rings as we want, and we only fill what we need. Same thing with this. We can draw as many lines out as we want, we just fill what we need. Brady?
So it goes by energy level and orbital,
Yes.
is when you stop?
Yes, because that's all based. It's all based on origin, or it's all based on energy. So here, we're going to fill these in this order. The arrows are parallel to each other, and we just list the arrow or list the orbitals with their energy level that the arrows touch in the order that they touch them. So 1s, 2s, 2p, 3s, 3p, 4s, blah blah blah. If you look at the Aufbau diagram that's pictured beside it, if we started at the bottom and every energy level that we hit as we went up, you'd see that this is the same order. Okay? Now, orbital notation is the arrows. Orbital notation is the arrows. So I have 15 arrows. 15 arrows. How many electrons go into a 1s orbital? 2, right? So I'm gonna put one arrow up, and I do half arrows because they're easier to draw. So I have 2 electrons in my 1s orbital. I have one up, and I have one down. Now I want all eyes. Each one of those electrons is a spot on the periodic table, represents a spot on the periodic table. The first and second electrons represent hydrogen and helium spots. It's in a 1s orbital. Energy level 1, L value 0, that's 1s. Spin up, the first arrow is up. Spin down, the second arrow is down. Where?
We have to like write that out.
No. This is what I will be looking for on your test. This right here. And the questions are worded very much like this.
And so you have to do an arrow for all 15?
You have to do an arrow for every electron, so all 15 electrons. Okay? The great thing about this is we've already got all of our orbitals and energy levels listed here, so now we just have to fill until we run out of electrons. So 2s, how many electrons go in a 2s orbital? 2. First one is up, second one is down. That represents the spots of lithium and beryllium. Energy level 2, they're in an s orbital, so our L value is 0, and the first one is positive 1/2, that's spin up. Second one is negative 1/2, that's spin down.
So will there be any cases where they're both spin up or they're both spin
No.
down?
Nope.
Okay, that makes it a lot easier.
Yep. Here,
Are you videotaping this?
yes.
Just wondering.
So then, after we get through those 2 spots, lithium and beryllium, then we move on to the spots boron through neon. Still energy level 2, but that's in the p block, right? So we jump across that empty gap where the transition metals are, and now we're at boron through neon, those spots. Those are in p orbitals, but they're still in energy level 2. P orbitals, energy level 2. Now, these are degenerate orbitals. So we have to put 1 electron on each orbital, or in each orbital, before any orbital can have 2. All right? So what I'm going to do is I'm going to go ahead and put 1 up on each. And then I go back and I put the other one down. And I know I can do that because I have 2, 4, 6, 8, 10. I haven't hit 15 yet. Now look at this. The first 3 to go in are spin up. The first 3 here are positive 1/2 for spin up. The second 3 that go in are negative 1/2 for spin down. The down arrow went in after all the up arrows went in. Because in our degenerate orbitals, this first p orbital corresponds to negative 1, 0, 1. So these 3 p orbitals are the m sub L values. That tells us the different orbitals within the set. Questions about that? Kara?
Can you repeat that again?
Yes. So these 3 orbitals correspond to the negative 1, 0, and 1. Those are our m sub L values. So these 3 orbitals, they're just different orientations in space, but we identify them by negative 1, 0, and 1, just like we do over there, negative 1, 0, 1. And then the first half of that is spin up because we put 1 up arrow in each orbital. And the second half is negative spin because we put 1 down arrow after each one has an up arrow. Yeah?
And you put the negative arrows in, because like, does each arrow count as 1?
Yes, each arrow represents 1 electron.
Is
Are you-
there a possibility of putting the down arrow before the up arrow?
No. It's always positive, then negative. Because our spin numbers are always positive, then negative. The first half is positive, the second half is negative. So it's always up, then down.
So like, never mind,
Think about it, let me know. Okay? Other questions about what we've done so far? How many electrons do we have left? 5. We have 5 electrons left. So I go to my next energy level and set of orbitals. How many electrons go in 3s? 2. 1 up, 1 down. How many electrons do I have left? 3, okay? But I have another set of degenerate orbitals. So I'm gonna put 1 arrow on each line before any line gets 2. Are they gonna be up or are they gonna be down? Up.
So that's how you finish that.
That's how you finish it. But wait, there's more. Have you ever seen those infomercials? No. So, let's look at our quantum numbers again. We're looking for that last electron, right? It's right there. What's the energy level? 3. The orbital set is p. What's the L value for p? And the m-sub-L value? This is -1, 0, and 1. So the m-sub-L value is 1. And the spin? Positive 1/2 because it's up.
It all comes together, it's just so much to remember.
It is. It absolutely is. Yes.
Okay, I'm so, okay. So when you started putting numbers under the,
So if you look at your picture of the orbitals, see here, -1, 0, 1. Each one is a different orientation in space. So each one of those lines corresponds, like the first line is this specific orbital. The second line is this specific orbital. The third line is this specific orbital. So one's gonna go in each of those, and then we go back and we put a second one in each of those.
how does that correspond to the numbers?
So the m-sub-L value is that little number there. So the last electron that went into a 3p orbital is in this one. And see how that's a 1? That's that value right there. All right? Questions about that one? So, the next electron configuration is just the electron configuration notation. It takes this and it makes it a little bit more of a shorthand. So what I'm going to do is I'm going to list, I'll change color, maybe that'll help. I'm going to list each orbital with its energy level and then use a superscript to indicate the number of electrons there. So the first one I'm going to do is 1s. How many electrons are in the 1s orbital? 2, so I'm going to put the little 2 up there. Then we go on to 2s. How many electrons are there? 2. Then we go on to 2p. How many electrons are in all of 2p? 6. Go on to 3s. How many electrons are in 3s? 3p. How many electrons are in 3p? There you go, condensed. This marker stinks. I can smell it through my mask.
So it's just gonna get easier if you do like first the orbital before you do that one. So you just.
And do it in whatever order makes the most sense to you. For me, like, it's different for me because I know, I can just tell you what it is based on where it's at on the periodic table. But that's more confusing at this point for you guys. Yes, Samira?
On a test, would you like just like show like both?
You will give me all 3. Okay? Any questions about this one before we go on to the third one, which is the noble gas notation? Bridget?
What is the red one called?
This is the electron configuration notation. Okay? Okay, now the last one is the noble gas notation, and what we're looking for there is a core that is a noble gas. All of the noble gases notations end in P6. So I'm going to give you the real easy shortcut way of doing it. Once you have one of these written, you're going to look for P6 with the highest energy level. So where do I have a P6 with the highest energy level? 2p6. So 2p6 is neon. I can figure that out by counting my electrons. 2 plus 2 is 4 plus 6 is 10. Neon is number 10.
So you
Okay.
go up to the highest one.
Wait, will you repeat that real fast?
Yeah, so I look for P6 with the highest energy level. That's gonna be 2p6 in this case. Then I just need to figure out what noble gas that is. You can, if you know it's an energy level 2, it's in the 6th column, that's gonna be neon. Or you can just count your electrons. 2 plus 2 is 4 plus 6 is 10. Neon is number 10. Okay?
So count them up until that point.
Yep. Including the P6. So I'm gonna put in brackets the symbol for that noble gas. So neon, in brackets. And then I just write whatever comes after it. 3s2, 3p3. It's like magic, right? Kara?
What's the point of the noble gas notation? Like, I understand if you find the core, which is a noble gas, but like, why is that important?
Okay, that's a good question. That's a valid question. So, I'm gonna expand that a little bit and say, what is the point? Which is what I feel like Chase is beginning after the last week. What is the point in all of this? There is none, it's just fun for me. I'm just kidding. So chemistry, the majority of chemistry is all about why do things behave the way they do? Okay? And most of that behavior is explained by the electrons. Most of that behavior is explained by the electrons. So I want to remind you that when I had that information over on that side board, one of the first things the first thing we had up there was Rutherford's model, and one of the things that I listed under that is that Rutherford's model did not describe chemical and physical properties of the elements. And it was because he didn't have the electrons in whatever form they were in. It is the electrons that are responsible for the chemical behavior of materials. Now, radiation, nuclear chemistry, that's all to do with the nucleus, the protons and the neutrons that are located in the nucleus, but everything else is a product of the electrons and what they're doing. So understanding the electrons and exactly where they're at and what they're doing at any time is critical to really understanding why different elements behave the way that they do. Knowing that phosphorus is in the 3rd column of the P block is going to help us understand that any other element that's in the 3rd column of the P block is going to have similar chemistry. And remember those atomic radii and ionization energies and all that stuff? Remember the pattern, the periodic law, the repeating pattern of chemical and physical properties? It is all related to how the electrons are organized in the atoms. So what is the point of this? To understand where the electrons are in an atom. Because that is going to unroll into all of the other things that we discussed this year. Why they behave the way that they do, how they behave, that is all tied to this. Now, I've said it before, I'm going to say it again. This is the most complex stuff that we are going to cover this year because it is so abstract. I can point to that periodic table over there and tell you that it's assigned that value because that's what we have labeled over there. But it doesn't have true meaning until you start to see how everything is connected to everything else. Do you understand how some of these things are all connected to each other? Chase, do you have a question then?
No. I don't understand it. Not completely. Like I do, but I don't.
You're not going to understand it completely. So once you let go of that, I think it'll be a little easier. I'm showing this to you and asking you to do these things because if you do have to encounter it later on, are you going to go into the science, math, or engineering field? Computer technology, any of those fields, you'll be required to take general chemistry. Anything, and most often, you have to take a gen ed anyway, that's science. Sometimes more than one. Aurelia.
Why do you have the 3s2 and 3p3 written behind them?
because from here back, that is neon. So everything that comes after it makes it phosphorus. Whatever's left, you have to write. Mira?
So say like 3P had like all negatives, you write 3P and then like 4S, whatever the
Yes.
next thing was.
You just keep going. But are you talking about for this one here? No, we would, if we had 3P6, then argon would be our core. And we would stop here and write whatever came after it. We're looking for P6 and the highest energy level. Okay? Trinity?
I don't know if you guys answered it, but I'm confused. Why did you stop at neon? Why didn't you go on to like have aluminum? Like, because if you added 3 more aluminum.
Because we have to have a noble gas. The noble gases are in group 18, so those are the ones all the way over to the right. Neon is all the way over to the right.
So like when you're looking at your electron form or this one, it's the highest.
So it's this column right here. These are our noble gases. So we want something from there in our bracket. Okay? Sierra, did you have a question?
If we were to write like a noble gas notation, like if we got a noble gas, would we just put like, let's say that was for neon, would we just do that as neon?
No, you'd have to write helium.
Oh, so you'd have to go to the one before.
Owen?
What if we have helium?
We wouldn't write a noble gas notation because that's already pretty short.
Okay.
This is for like if we're talking about uranium. Right? Amira?
Wait, so do we need to memorize that for our test?
What do you mean memorize? Memorize what?
Like neon, aluminum?
No, you will have a periodic table, you just can't have that one. What I'm hearing come out in this is that you just need practice. I know you need practice, but I want to walk you through one before we go to practice. Because if I just throw it at you, you're gonna shut down and it's gonna be worse than it is, trust me. Okay, the last thing on here is it paramagnetic or diamagnetic? So here, you're gonna wanna write this down. That one was from Columbus. I'm not that important either, so. All right, you ready? So we need to know, we need to look at, I think it's easiest to see it in our orbital notation. When it is paramagnetic, you have electrons that are not paired. When it is paramagnetic, you have electrons that are not paired. That's a lot of rings. So do you see how we have up arrows here but no down arrows to go with them? Those are unpaired electrons. Yes. If it's paramagnetic, you have unpaired electrons.
So does diamagnetic mean that all electrons are paired?
Correct. Diamagnetic means all electrons are paired. So for every up, there's a down.
You think it'd be the other way around?
Yeah. I know. Yes, Chase.
So with that, does it mean just for like specifically like the 2P right there? Or does it mean like the entire,
It means the entire thing.
so the entire configuration?
Yes. Yes. But remember, we're only writing these electron configurations for ground state, so you should only have to look at the end. There should be no holes anywhere else. Okay? Now, what that means, paramagnetic means that the electrons align in a magnetic field. That's not important for you to know, but that's what it means. And when they do that, they have some magnetism to them. When they are diamagnetic, the magnetic fields repel each other. So aligning those, now I would not have taught that to you except Clark State says that I have to. So paramagnetic, you have unpaired electrons, diamagnetic, they're all paired. And paired means there's one up and one down. There's every one of the one ups has a one down. I don't know. For every up arrow, there's a down arrow. That's a better way to say it, I guess. So, where are we at?
I feel a lot more comfortable with this than I did the, like, photo electric, like the beginning stuff.
Same.
Okay, that's good. I think, well, let me do this first, because I think this is gonna make you uncomfortable again.
Right there.
And move. It's not recording. I'm just kidding, it is. I had to lighten the mood a little bit. Okay, that was mean. Okay. Of course there are exceptions. There are always exceptions. And the only exception we're going to talk about is in the transition metals, group 6 and group 11. So, what is that, chromium? Let me show you with chromium. Oh, I did that one. Okay. So I'm gonna put up here the orbital notation for chromium. What time is this class over? Do I yell sun every day? Sorry. Okay. So this is the orbital notation for chromium. And this is what we would predict, and this is incorrect. Because what happens is it naturally rearranges itself so that 3D drops down in energy below 4s. What happens is that one of these 4s electrons, that negative electron, that downspin, gets promoted, means it gets bumped up to 3D, and 3D becomes half filled. So what happens then is it looks like this.
Why did it kind of positive?
Why did it what?
Kind of positive, like a positive arrow.
Because positive 1/2 has to come before negative 1/2. Sierra?
So basically group 6 and 11, like the end result, the end D orbital is always going to be half or full.
Yes.
So never D.
For groups 6 and 11, yes. The D orbitals will always be half filled or completely filled, and the s orbital before it is just going to have one electron in
Would you
it.
ever have to, like if there was 2 spaces that you needed to fill, we have to go back to one.
No. If there are 2 spaces here, then there are 2 electrons in 4s. Okay? And there'll just be 3 electrons in 3D. It's only groups 6 and 11 that this happens with. Already? What? Yeah. In group 6 and 11, one of the s electrons will be promoted to either half fill or completely fill the d orbitals. Okay, wait. One thing, 2 things. You're not going to take a test on Thursday. I'm going to move it back to like Friday. at this point. We'll see how the next couple days go. Tomorrow will be a day in class where you just practice this. Okay? So that's the plan for right now. All right?